All right, let's pick up where we left off here. In the last few videos and stuff, we've been discussing data structures for C++. We got into vectors list, which we found that both of those are very similar to arrays, which is pretty much a variable that is holding an assortment of values, whether it be assortment of numbers or strings. Those numbers can be numbers or characters, any kind of data you want to put into it. Characters, numbers, grades, cars, accounts. I mean, all kinds of different stuff, whatever you can think of. You need a place to store them. Lists, vectors, arrays are a great place to store them. And so learning about all three of those and stuff, each one of them being a little bit different from the other one, but all of them being useful for something, um, is where we started. Where we left off was stacks. I haven't done anything with stacks yet. I'm not 100% familiar with it. I've heard of it a couple times, but let's get into it and find out what this is real quick. A stack stores multiple elements in a specific order called LIFO, which LIFO stands for last in, first out. To visualize last in, first out, think of a pile of pancakes where pancakes are both added and removed from the top. Um, yeah, or eating like a sandwich or however you want to do it. So when you remove a pancake, it will always be the last one you added. This way of organizing elements is called last in, first out in computer science and programming. Unlike vectors, elements in the stack are not accessible by index. So it sounds like a list because you can't really access elements in a list randomly. Like you can't access just the third one or second one or whatnot. You kind of have to reorganize the list, as I was showing you in my last video and stuff, how I've reorganized the list a little bit, remove the top one. If you remove the top one, that means the second one becomes the first, and that way you can change the first one, and then you can add something back to the top one, put it back in there. So it's kind of like a pancake, like they're saying and stuff. When you want to change something out and stuff, you have to remove one, two, three, then change that one out, and then put them back in the order they were in, if you want to keep the order. Where vectors and arrays and stuff, you can change out. You can slide one out and slide one back in, or slide one out, kind of like it's more organized as a case and stuff, where you have CDs or whatever, if you remember those. But yeah, so when we remove, let's see here, where to leave off. Unlike vectors, elements in the stack are not accessed by index number. Since elements are added and removed from the top, you can only access the elements at the top of the stack. To use stack, you to use a stack, you have to include the stack header file or library. So, and I got an example of that. So let's clear out all this code. This is for uh, lists right here. So we're going to clear all this out right here. Start fresh. And go ahead and clear this out right here as well, and clear this out, and make this look brand new. Okay, so stacks. First thing we got to do is add the library. Include, and no, I don't know about this stuff yet. I'm learning it pretty much right now. First time I've dealt with stacks, I think, so. We got the example right there, which is the library. To create a stack, which scroll down here and let's take a look at it. To create a stack, use the stack keyword and specify the type of value it should store within angle brackets. So kind of like a list or a vector and stuff, you're going to do the list or the vector. Well, the stack is going to be the same way. Then you're going to have the angle brackets with the type inside the angle brackets, it looks like. They got an example here. There's a comment. I'll go ahead and add the comment first. Create a stack of strings called cars is what they're using. I thought they were going to use pancakes, honestly. um, and most of the time, um, in most of W3 Schools examples, they have this right here at the top. Using namespace standard. Oops, is what STD stands for. I don't use that, but you can if you want to. If you want to put that in the top and stuff and practice your comment lines to where you're commenting your code out, you can do that right there. And then you can kind of follow along with what I'm doing here. Standard stack, yeah. And then the angle brackets, which we're going to have the type in this case is going to be string. So again, standard, since I got the standard commented out at the top, string, angle brackets, and then cars. And at this point in time, all we're doing is declaring it. Save it like that. So yeah, we got the library, we got the using standard, but I'm not using that. So instead, I have to put this standard in for string and stack both. How do you know which ones when to use it, when not to use it? Well, stack. I didn't really know if stack needed it or not, but I assumed it did, since so far everything else, list, vector, have all needed it. I know that string is a type, and yes, it needs it as well. Most of the time when you're using strings, though, you would need the library for that, but I think there's been some changes and you don't need it anymore. The only other things that I know you would need it for, if I didn't have it in there, I would end up getting a little line underneath the code right there that would indicate there was a problem. I could mouse over it and it would tell me that it is missing something, pretty much. Identifier stack is unidentified, type definition standard. And that's what I would realize, that maybe I'm missing the STD or the standard in front of it. How's another way I can go check? Well, in this case, I can't, because I normally have a click button right there you can click on, but it's not there. It's been in the tutorial section quite a bit. It's in previous sections as well. So it's just something I've come to pick up, that W3 Schools uses the namespace at top where I don't. What's the difference? There's not really much of any difference. But if I was to use the word stack as a keyword, like right here, the program or compiler would maybe think that this right here is part of the library and would be questioning whether or not this is actually a variable name or a keyword. And in this case, it's not a keyword. But having this right here in front of this, the compiler can simply see, okay, he's not using this up here, he's using it right there. So this right here is obviously a variable name. So, but they don't have stack right there for the variable name. They have cars. So we'll keep it cars. Okay, note the type of the stack string in our example cannot be changed after. So just like vectors and uh, yeah, vectors and lists and stuff, once you declare the type, it's stuck like that. So all the elements are going to be of string type. So you'd have to create a different stack if you want some different type of value in there. So far the way I'm thinking about this, I don't. Some people have asked this question: why do they use the word vector um, for a list of elements? Where an array. So far we've found that the difference between these are an array is a list of elements, and you can change them out, but you can't add to them or subtract from them. Once you create it, it's created. Once the program runs, there's no changing it. You would have to go through and rewrite the program and tell it, hey, we need to add another one. So instead of being 5, we're going to have 6, and then add the other one. Where a vector, you don't have to do that. You can simply add more and subtract more from it. Add more, subtract, change them out, all that sort of stuff. What you can't do in vector that you can do in array is you can change the type in a array where you cannot in a vector. Um, yeah, I believe in an array you can set it to auto and have just as many different types as you want, but I'd have to go back through that information to find out for certain. And then a list, the difference between a list and a vector, and I just literally went over this, so I'm trying to test my mental capacity on remember this. remembering these things and see if I can actually remember it. So a vector, we can um, when you can add things, you can subtract things from any location in there. You just can't change the type of the list. You can't change the type either, but it more or less stays in order. So if you add something, it goes to the front or the back. It doesn't go in the middle. With a vector, you can add it anywhere you want to. Um, yeah, I was trying to remember the differences and stuff, and I'm struggling to do it. I have to go back to the sections to do it, but yes. So now there's 4 different things. We got vectors, lists, and stacks, as well as arrays for holding data, depending on what you need it for. And yes, you can use all 4 of them, just like we can use functions and structs and class. Just depending on what you need it for is how you're going to use it. All right, so let's keep going. Note you cannot add elements to the stack at the time of declaration, like you can with vector in list. So we are going to create our list of cars here. Um, so the way I've been doing this is create it and then put the list right here. Again, we're going to have the same vehicles or cars as we have in the past. I assume there's got to be a comma after each one. Just like you do with the vector list array, so forth and so on. Ford, and then Mazda. And then at the end of that, you still have to have, yeah, I'm trying to get that to go away, and it won't. Just like with an array or anything else, you have to have the semicolon after it to close it off. What's this right here? Do we have a mistake in there? No, I don't see one. I have a comma after every one of them. That starts it. Yep, it should be fine. We should be able to print out the entire thing. Okay. So we got our 4 right here. That's that previous example. Now let's add some to it. To add elements to the stack, use the push button. So the push function seems to go with so far every one of these. The vector, the list, the stack. I think it even goes with arrays. So I don't know if it's built into these, but I'm assuming that these different ones and stuff because people wanted to just do a little bit different here or there. When they added the one to it, they wanted to add the last. When they deleted one, they wanted to make sure it was deleting from the last. But anyways, so we got another example here. They have the same setup right here we have, except for they don't have a list here. Instead they add the list. But let's see if we can add to this or if we need to add to it outside. I think we can add to it. Actually, there was something up here. Note the type of stack cannot be changed after it's been declared. Yep, we know that. You cannot add elements to the stack at the time of declaration like you can add elements to the stack at the time of declaration like you can with vectors. So, but they're adding right here. So I don't understand that. To add elements, you cannot add elements. So why would they? So you cannot add elements to the stack at the time of declaration like you can with vector. Maybe that's what the issue is. Maybe that's why I have a problem right here. Let me see if I can output this. Let me see what happens here. Just to see if I understand this right. Cars. Okay, so we got an issue here. Do I have the wrong one in there? I may have the wrong one in there. No, I don't have the wrong one in there. I didn't have the wrong one in there. So we got another issue right here. So maybe they're given the example that this example right here, and maybe where my squirrely line is therefore because of the fact of stack, you can't do this. With a stack, you cannot actually put in elements like this. You cannot pre-declare elements. You have to add them in after you've declared it. So that could be the problem we're having here. So let me clear this up real quick. We're going to declare it, clean this up right here, because we're not going to use that. Um, so we've created a stack. Now we need to add the elements to it. Got a comment here, add elements. So pretty much a stack starts empty to begin with. You just declare it and start empty, and then you add things to it as you go. So cars dot push parentheses Volvo cars. Actually, you know what? Simpler thing to do would be just to take this, copy it, and we got 4 more to go. So, and then change the words inside. So instead of Volvo, Mazda. Instead of Volvo, Ford. Instead of Volvo, BMW. Okay. And save. It doesn't have us printing out anything like that yet. The stack, let's see. The stack will look like this. Remember that the last element added is the top element. So in this case and stuff, normally in a vector, whatnot, when we add things, it adds to the bottom of the list. Well, in this case, it's the opposite. When you have a list a list of elements in either a list or a vector or an array, and when you're adding to them or whatnot, an array you can't, but normally it adds to the last one. So the last car would be Mazda. If you add another one, it would go below, 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 below. In this case, we add one to it. This Volvo starts at the bottom. Add another one to it. BMW, next one up. Ford, next one up. Mazda, next one up. So it's actually in the reverse order. So I guess if you wanted to change the order, then you would have to change which ones go first. Okay. Accessing stack elements. You cannot access stack elements by referring to index numbers, which is the same thing as with lists. Like you would with an array. Oh, sorry. Like you would with an arrays or vectors. So yeah, lists you cannot access particular elements. You can only access the bottom or the top one. Arrays and vectors, you can access any one of them you want, wherever you want. Apparently, stack is the same way. You cannot access anything in the middle. You can only access probably the top or the bottom. In the stack, you can only access the top element, which is done by using top. So apparently you can't even access the bottom. You have to remove every one of them and then start the list all over again. So, got another example here. Oops. Access the top element. So, standard output cars dot top parentheses finish save. Okay. Now this is one of those, this is where I was talking about and stuff. If you're trying to write code and stuff, your code is not coming out the way that you think it should, which you should definitely check if you're new to this. I'm going to run this real quick, and we're just accessing the top one right there. So the top one being Mazda. Now, if you're not sure if that's what should be coming up, which is this right here, these first 2 lines right here are part of the path to trying to find this file if you're new to this. The bottom one right here is waiting for command, and that's what this right here is as well. Everything after this angle bracket, though, the blue, the green, the white, and the yellow after that are paths to finding this particular file or writing this, placing this file or whatnot. This right here, which is after the squirrely brackets in practice, which is what I got this called practice, is the actual output you would see in a window. And then once the program is finished, it's prints this up again saying pretty much I'm waiting for another command. What do you want me to do next? So we're just outputting the top one right here. What was I getting at with that? Yeah, oh yes. No, I just lost my train of thought again, darn it. Anyways, we got our list. We're accessing the top car. You can't access any others besides the top one. Hold on a second. So if we want to change any one of these, we have to pretty much remove from the top to the bottom, it looks like. Oh, that's what I was getting at. This right here. So you get this output right here. You want to make sure it's the right output, especially when you're trying this your first time. So you can click on the try to button and it shows exactly what the code's supposed to look like, even with the comments in there. If your code does not match with the code that they have in there after you type this, it will not have the same output. So if you're not getting the proper output right here, you might go to the try it part, which opens up another window in your browser. There's the output right there. This is the code that they have written. So you can definitely check and see if you got the right stuff or not. Pay attention to this because I have the standard in front of each keyword or each type. They do not. Their stack does not have the std : string the same way, output the same way. That is all up here in the top. Just like what I have up here, but mine is commented out. Theirs is not because they're using it up there. So getting back to this, that's where my train of thought went. Changing the top element. So if we want to change the top element, you can use the top function to change the element of, okay, so I'm assuming cars, this right here basically written out with a new change in it. So let's go ahead and do that real quick. We can go and just add to it right here. Comment, change the value of the top element, cars dot top, parentheses, assign Tesla. And then access the new top element. So pretty much we just took the top pancake off and put a fresh pancake there. It had too much syrup on it. There's never such thing as too much syrup, right? Maybe butter. Now I'm going to print it out. Cars.top. And we should get Tesla now instead of Mazda for our output. Save it. Run it. Actually, we got both of them. I know why we got both of them. Because we still got this right here in there. So this was the old top. In fact, I will go ahead and add that in there. Space, quotes, old top element in our stack. Once you get used to doing this stuff, you should probably start working on actually putting in notes for yourself like this, just to get used to it. And then we're going to create a new line. Actually, no, we're just going to create a space. Yeah, no, we're going to create a new line. New line, yeah. All right. And unfortunately, no, I'm missing one more thing. There we go. And then this one right here, we're going to change it as well. Do I have a space in there? No, I don't. Okay, I didn't think so. Down here, I'm going to do the same thing. New top element in our stack. I got to put a space in there too. Otherwise, they'll combine. Enter, tab, space, space, arrow, angle bar, angle bar. And then we don't need anything else at the end of this because this is the last part. So we'll save it, run it, and it looks a lot better. Old top element on our stack, Mazda. New top element on our stack, Tesla. Now, 2 or 3 weeks ago, probably 4 weeks ago, I could not do this. For one, I didn't know about any of this. I didn't know about stacks really that well until today even. The push, the array I did, which I'm getting very used to arrays doing this, by the way. So if you're not used to arrays, you can get used to all three of them this way, but then you're going to have to start memorizing which one is different, which one does what, because then you're going to be like, well, was it an orange car or a blue car or a red car? What am I talking about right there? Well, was it an array, a vector, a list, a stack? Which one can do this? Yep, sort of thing. I get those confused all the time. Um, but yeah, weeks ago and stuff, I would never have thought to add in this text right here to indicate, so this is the old one, this is the new one, and what my actual code is doing. This is simple stuff to do. It's probably not for a beginner, it's not, sorry. For a beginner, it's probably not simple. It's going to take you a little bit to get used to writing out these things, typing all this stuff in really quick. And in fact, I'm not even that used to it myself. There's other people that can do this so much faster than I can. But that's fine. So, remove elements. Not too bad on time so far. Remove elements. You can use the .pop function like we've been using before. I think pop remove or pop front or something like that is what we were using before. But .pop function to remove an element from the top stack. Okay. So we changed the top one out using top and changed it out, and so it replaced Mazda with Tesla. Now we're going to remove Tesla altogether. So we have our 4 in there. We're going to actually create another one now. So we're going to recreate the output after we remove Tesla. And then we're going to, oops, yeah. Then we're going to print it out again. So cars dot pop parentheses, and that's actually all you need to do, because that by itself will remove it. But there is a thing right here I need to add in there, which is a comment. Remove the last added element, which is Mazda. No, in this sense, it's Tesla. That's the last one we added. We're just adding to our code. We're not actually redoing our example. I figured it's quicker this way. I'm getting used to it now. Then we have another comment here. Access the new top element, which is not going to be the same as what they have in the comment there. But I will have to make another adjustment. So we're standard output after removing the top element in our stack. Cars.top parentheses semicolon, and then come back up here because we need to make sure it separates here a little bit. New line. Save. Right. So now we got old element in our stack was with Mazda, the new element in our stack, which was Tesla. Now after removing the top element in our stack, it's Ford. So now we only have 3 elements in the stack. I imagine you can do the same thing with size. Yep, we're going to get to that next. So how to find out how many elements are in the stack? Use size. So the next part right here. It shows it right there. Let's see, cars, empty. No, it's the check. Okay, so how many elements are in our stack? Actually, you know what? I'm not even gonna put the comment in there. Standard output. How many elements are in our stack now? And enter. My cat's gonna start screaming at me here in a minute. Cars dot size parentheses, and you go back up here and create a new line now. New line. Save it. That'll. Oops, I forgot it again. I do that often. Save it. Now we should have 3 elements. So now we have 4 lines. How many elements are in our stack now? 3. All right, check if it's empty. Okay, that's easy enough. So we need to check and see if it's empty. First, we can do it one of 2 ways. We could do it the way where it indicates a number, um, standard output is our stack empty. 1 for yes, / true, 2, let me see, put a question mark there, comma there, 2 for no / false. Cars dot empty, and then back up here again to add the new line. Save it, run it again, and there we go. Is our stack empty? 1 for yes or true, not 2. I made a mistake. It's not 2, it's 0. 0. Save, clear, run. Okay, 1 for yes, 2 for, or 0 for no, false. And obviously no, it is not empty. So the reason this was so much easier for me is because we use top. Well, we don't use top. We use, well, maybe we do. No, we use push, pop, front, end, back, size, all these different keywords right here. Yeah, trying to remember them all. I'm getting there. Some of them, yeah, they're sticking pretty well. Some others, not so much. I'll have to definitely go through this again. But yeah, we got the 1 and the 0 in place. But what if we want the actual true or false thing? Well, we got to add that in there too. So standard, that'll pretty much end our video here. Output, standard, alpha, Boolean alpha, sorry. You would think I would be used to that by now, but apparently not. Boolean alpha. Let's go ahead and add this in here. New line. And then standard output. Just, we're going to be a, yeah, just answer the answer. Yeah, maybe I'm spelling that right. Answer. Yeah. Just say true or false, please. And cars dot empty. Save, run it one more time. There's a last line. Just say true or false, please. False. It's not empty. See, I kept adding to that. Yeah. Not too terrible hard. For beginner, I mean, for me, at start and stuff, yeah, it was. But now I'm getting used to this stuff, yeah. And yeah, there's 42 lines of code. We can clean it up and kind of mesh it all together and stuff. Get rid of the comments, make it cleaner. Sorry. Now let's go ahead and clean it up real quick and then I'll end the video. So get rid of these comments here. It might be a little harder to read for some. But we'll get to see how many lines of actual code we have doing this way. All right, that reduces it down to 28 lines of code, but it's a little bit harder to read this way. Granted, what's funny is with all this, I can actually take and clean this up even more. Delete, backspace, tab, space, delete, backspace, delete, tab. There we go. Delete, tab. Oops, too many. All right, that cleans it up just a little bit more. Instead of having all the standard output, we have nothing in here now. We just have one, and it all feeds into the same thing. A little bit harder to read, but it shortens it all up, makes it look a little cleaner and stuff. Now, if we want to read it, we're gonna have to start separating everything out and stuff. That way, it's a little easier to read. With it being this small though and stuff, I mean, this right here is easy enough to read. You get down here to where you're at line 10,577, it might be a little more difficult. And it still all works. Still shows the same data. Okay, let's move on. Queries. Queries is going to be our next case. But we won't get into that till the next video. So again, if you like the video, hit the like button. If you have any questions, comments, or you want to make a correction to something maybe I've said, because I'm not educating this, I am learning this, I am sharing my journey of learning this. As you can see, I am improving. I will continue to improve every day. But yeah, comments are there. Post them in there. I'll try to reply to them when I can. But everybody's opinion, open to their own opinion about this sort of stuff, especially since this is not me educating on anything. So, but until then, I will see you in the next video where we start with queries.